Alright, here's a recap of the chemistry outlining session. What you should have right now is a textbook, line sheet of paper. Hopefully you have either this textbook, the 8th edition, or this one, which is the 7th edition. If you happen to get one of the other textbooks, the information you'll need will be on one of the slides in the PowerPoint that's attached. So on book reading. When you're reading the textbook, it's important to actually take notes. Taking notes, writing equals learning. For AP Chemistry, you're going to use an outline format, not Cornell notes. Why not Cornell notes? With an outline, you can differentiate between definitions, equations, steps, and example problems. Cornell notes are for a lot of big ideas. Chemistry is a lot more process-oriented and analytical, so an outline is going to be more beneficial. With an outline, you're going to use a numbering/organizational system so you can keep track of what's where. Make sure you include important details, definitions, concepts, and record any necessary equations with units and other important steps that might be necessary. But one thing that you're going to will be a little bit of practice is finding a balance between being concise but not too brief. So having enough information to make sense, but not being too short that you have no idea what's going on. So we're going to do some outline practice right now. Turn to the section on free energy. In this textbook, it's page 759. In the black one, it's 783. If you don't have either of those, then they will be on the next slide. So read the first paragraph on the page. Pause this video right now while you read that. Alright, so one thing to start off with is making sure that you have a heading. We just started somewhere in the middle, but rarely you'll do that. You'll usually start at the beginning. So that was 17.4 or 18.4, depending on which book, free energy. So free energy is a thermodynamic function related to spontaneity and useful to address temperature dependence. Basically, I took an important definition from that first paragraph, called it number 1. Second useful thing of that paragraph was an equation, where G equals H minus Ts. So I noted that H is enthalpy, T is temperature. I wrote here that it has to be in Kelvin, because that's important, and S is entropy. That's about all the useful information in that particular paragraph. So the next one, read the first half of the next page. So when it gets to the equation that says at constant T and P, you can stop right there. Pause this video and read that. Alright, so this next part. The important information here is that when we look at this thing, Gibbs is for a process that occurs at a constant temperature. So put that in bold. Then we have an equation. So if we're at a constant temperature, then we have delta G equals delta H minus T delta S. And all quantities are referring to what happens to the system. I didn't need to rewrite what H, T, and S mean because I have that up above. The last part there was to rearrange the equation, and we can determine delta S of the universe is equal to a negative delta G over 2. Now this might not actually mean anything to you at the moment, because you didn't read 17, 1, 2, and 3, but I wanted to pick something that we would actually have to analyze. Alright, so finishing up that page, pause this. So the last part that I added, important information on that page is that a negative delta G is spontaneous. If delta G is negative, then that would result in a positive delta S. That was basically the takeaway information from the rest of that paragraph. The last page, the one on the right, read that over. And what we'll notice is it talks about the effects of temperature. Well, in 17.3 there was some useful information from that. So when I did this outline, I referenced my previous material. And just as a recap, spontaneous is negative delta G. Realize we did just say this twice, but it was important enough that I included it twice because the textbook really hit on that. It had a table and it had an example. And then the last part is that some processes will change their spontaneity or how spontaneous, whether or not spontaneous, depending on temperature. That was like the main takeaway at the end. So the last thing is read through the example problem any answers. So it's in my outline, what I did is I just said, example 17.5, I wrote the page number down and said, this involves taking delta G to determine temperature when a process is spontaneous, given a specific value of delta H and delta S. Here I just wrote what the problem was about. It's up to you if you want to go through and show this work in notes. Usually in class the example problems are the ones that I will go through or we'll talk through as a class. So you can have that in your notes if it'll help you refer to go back to it. And if you need to do problems over and over again. If you have any questions, there's a spot on this Google form below. Otherwise, that is it. You've got your summer assignment.